I'm a former fisherman that's become a regenerative ocean farmer in the time of climate change. We use the entire water column to grow a mix of regenerative species, seaweed and shellfish, in order to capture carbon, nitrogen, rebuild reefs, and create jobs for local communities. What's powerful is that we can grow incredible amounts of food in small areas using no fresh water, no fertilizer, and no feed, making it hands down the most sustainable form of food production on the planet. Our goal is to train 10,000 farmers in the next 10 years.
The Marina Trash Skimmer is a blue tech innovative solution for capturing and removing litter as a last line of defense for improving ocean health. The skimmer processes over 350,000 gallons of water per day, removing litter, adding dissolved oxygen to improve ecosystem services, and activating and inspiring the community that improving ocean health starts on land.
So in my lab, we're developing new in situ chemical sensors to be able to measure two important greenhouse gases, methane and carbon dioxide. These gases are important in a range of ocean locations from the deep ocean to coastal Arctic waters. We're developing systems that utilize infrared lasers, such as this one, to be able to measure these gases dissolved in seawater. Now, it's important for us to be able to measure greenhouse gases, both to understand the ocean, but also because they have a direct impact on climate change.
Our innovation is the creation of immersive data experiences, particularly the Large Interactive Laser Light Field Installation, or LILY, as we like to call her. Ocean data and marine wildlife are projected in a pseudo-holographic volume, viewable by multiple groups of people without any kind of head-mounted display. We believe data can be informative and beautiful. When you make data visualization into an immersive experience, you can reach the participants emotionally as well as intellectually.
Think of the seafloor as the lungs of the ocean. The seabed is a sump for ocean pollutants and a recycling plant for ocean nutrients. We measure the health of the seafloor using a novel technology known as sediment profile imaging, or SPICAM, which allows us to peek beneath the surface of the seafloor in a profile perspective, analogous to as if you're holding up an ant farm and peering to the side. And we take this approach because it's minimally invasive and allows us to look at and document seafloor processes in real time.
Robots for Whales is an oceanographic system where we use robots like mobile gliders or moored buoys to be able to record, detect, and then send that information of what whales we are hearing in real time to a website. And so this information allows us to get 24-hour coverage of certain areas for when endangered whales, such as the North Atlantic right whale, are in certain areas. And we can then use this information to pause harmful activities or to ask ships to slow down or to guide directed surveys to these areas when whales are present.
This is a miniature isopycnal float. We call them minions for short. It's a sensor platform that we drop off from the ship. It sinks to a dark portion of the ocean we call the twilight zone, hundreds of meters below the surface, and reaches a neutral density and drifts. While it drifts, it snaps photos of marine snow and measures oxygen and temperature changes. When it's done, it drops a weight, rises to the surface, and transmits its data through satellite. The data helps us understand a process called the biological carbon pump, how carbon moves and is transformed through the deep ocean.
Our research team have modified an underwater glider and developed an unmanned surface vehicle for iceberg mapping. These marine robots can carry a wide range of sensors and to take measurements around the iceberg at a really close range. With the measurement, we are able to reconstruct the iceberg shape and to evaluate the environmental conditions around it. This information are critical to advance our knowledge on iceberg melting that impacts the global climate and the sea level rise.
Deep sea equipment is generally very large and expensive. Here in my lab at the University of Rhode Island, we're making tiny 3D printed deep sea cameras. We call this DeepEye. This is a fully integrated camera system that has a chargeable battery and computer inside of it, and it can go thousands of meters deep. We can make it in any size or shape that we like, again, because it's 3D printed. And this type of technology enables more people to explore the deep ocean easier.
Whales tend to get entangled in ropes associated with trap fisheries, and this is a significant problem, particularly for the severely endangered North Atlantic right whale. Ropeless fishing is a way to allow fishermen to continue to fish, but not entangle whales. And ropeless is a way to both retrieve and mark the location of gear, which will help sustain healthy populations of whales.
Just this summer, in July, the North Atlantic right whale was declared critically endangered and added to the red list of endangered species by the IUCN, the last classification before they are completely gone from the wild. NOAA's Fisheries Division found that in order to avoid extinction, the population simply cannot afford even a single death a year. But since 2017, 31 deaths have been reported. As we've just seen, there is a blue tech solution to help avoid this from happening. Joining me is Dr. Mark Baumgartner, Senior Scientist in the Biology Department of Woods Hole Oceanographic Institution and Deputy Director of the Ropeless Consortium. Mark, it's great to see you. Thank you for being here with us. Can you tell us a little bit about the critically endangered North Atlantic right whale and why we need to take action?
Absolutely, Danny. It's great to see you. Thanks for having me on the program. So North Atlantic right whales, as you mentioned, are severely endangered. There's only about 400 of them left on the planet. They live along the east coast of the United States and Canada, and the population has been declining since 2010. 2010, we had almost 500 right whales in the world, and now we're down to 400. And there's a lot of concern about this decline, as you said, slipping towards extinction. So right whales are killed by die because of two major issues. They get hit by ships and they get entangled by ships. And these are really serious issues. Right whales don't die of natural causes. They don't die of old age. They die because of ship strikes and fishing gear entanglements. So it's really an urgent problem that really is begging for really solid solutions.
So with that said, what is the solution?
So the solution I'd like to talk to you about today is called buoyless or ropeless fishing. It's a way to allow fishermen and whales to coexist in the same place and not worry about entanglement. So if you go to a restaurant or you go to a store and you buy lobster or crab, that lobster or crab was caught using traps at the seafloor. And the way it's fished is there are many traps connected by ropes. And at the end of this string of traps, there's ropes called buoy lines that go up to the surface and are attached to a buoy. And I'm sure many of your audience know very well what lobster buoys look like sailing around the world. So most entanglements of right whales, and not just right whales, other species of whales and sharks and endangered sea turtles, most of these entanglements happen in these buoy lines. So buoyless fishing or ropeless fishing is just simply removing these buoy lines from the gear. And in order to do that, you have to replace the functions of the buoy line and the buoy, and that is to be able to retrieve the gear and to be able to mark the location of the gear. And so we're borrowing technologies from the oceanographic community, from marine industry, to be able to efficiently, cheaply, and safely retrieve gear and mark the location.
Well, that sounds super innovative, Mark. And for those who are listening right now, what can we do to support and to help stop these creatures from going extinct on our watch?
Yeah, it's a challenging problem, and the development of buoyless fishing is really in its infancy. But what's really exciting is that there are fishermen that are very motivated to see this happen. There's many fishermen in both the United States and in Canada that are not allowed to fish in areas because of the presence of whales. And so they're highly motivated to get back into these areas to fish. And so they're really interested in exploring whether buoyless fishing can work for them. There's also conservation groups that are excited about the possibility of a technology that could reduce lethal entanglements of North Atlantic right whales. And there's scientists and engineers and manufacturers that are really eager to work on this problem. What's really lacking right now, because no government is mandating that buoyless fishing be used, there's no market to sort of spur commercial development of this technology. And so what's needed is investment from the philanthropic community and investment from governments to really accelerate the development of this technology, because right whales, quite honestly, don't have a lot of time. They don't have a lot of time for us to figure this out. And so investment now to accelerate this development is going to be really important for saving right whales from extinction and saving fishing industries from having to stop fishing because of the issues of lethal whale entanglements.
Well, Mark, thank you so much, and good luck with your important and urgent work. I, for one, will be supporting your efforts, and I'm sure many of us here will do as much as we can for this amazing species to survive while we're here.
Thank you, Danny.